1. All right, greetings and welcome, friends. We're here with opening our geometry class 1.1 from our Common Core textbook, Big Ideas, and we're going to be defining points, lines, and planes today, or actually undefining in some ways. This is kind of a bizarre idea, but some of these are undefined terms that we have listed. And in geometry, the words point, line, and plane are undefined. These words do not have formal definitions, oddly enough, but there is obviously agreement about what they mean. So here we go. So a point has no dimension. A dot is the way we visually represent that. And in terms of text, you could refer to it as point A, like so. And so that point represents kind of the locality of where it exists. In our case, we're going to be working primarily in 2 dimensions for most of this text, but today we're actually going to even be thinking about things 3 dimensionally. Let's see, so a point has no dimension, so there's no length or width or height to it. You guys perhaps are used to the coordinate plane from algebra, where in 2 dimensions you might have referred to its location with an x comma y, an ordered pair. 3-dimensionally you can have an ordered triple. Maybe you've never heard of that one, but yeah, so that's a point, and that's the way we refer to it in a diagram, labeling it. Usually capital letters are reserved for points. Let's see, a line has 1 dimension. It is represented by a line with 2 arrowheads, so it travels infinitely in both directions. It extends without end, as they said right here, through any 2 points. Okay, so now we're referring to a line and referring to kind of our previous understanding. Through any 2 points, there is exactly 1 line. You can use any 2 points on a line to name it. All right, so here's the line. You could refer to it as line L, okay, if I'm referring to the entire line, or I could refer to it as line AB. Line BA, right? Because either direction, it doesn't matter in the case of a line. It's traveling infinitely in either of those directions. And yeah, so it says through any 2 points, there is exactly 1 line. 2 points, I would suggest, would be referring to distinct points from one another. They could not be coincident to each other. Thoughts, question?
It's kind of strange because a line is represented by a line.
Let's see, where did it say that? Oh, it, as in, right, so it is represented by a line with 2 arrowheads. So this is the artistic term, perhaps, which in geometry, lines are straight, not, I mean, you might call this line art, right, if you're drawing your cool stuff in art class. But yes, this word line is referring to a straight edge construction with those 2 arrowheads on it. Okay, and then a plane, P-L-A-N-E, has 2 dimension. It is represented by a shape that looks like a floor or a wall. Wow, but it extends without end. So imagine that this is actually traveling in all of these 2 dimensions infinitely. So we don't restrict it to just that region or that location. But yeah, it's traveling in all of those dimensions infinitely, at least according to kind of the ideal mathematical description of it, like what we're imagining, for instance. And so yeah, it is represented by a shape that looks like a floor or wall. Oftentimes we'll draw it kind of like a parallelogram, so imagine a perspective isometric drawing, perhaps, if you've taken a drafting class, of imagine this being a square from a top view if I was to look down at it, but I'm kind of looking at it from an angle. And then here it makes this claim. Through any 3 points not on the same line, so those points are not collinear, is the word that we'll use later, there is exactly 1 plane. You can use 3 points that are not all on the same line to name a plane. So what we've got here, we could refer to this as plane M. Notice the M doesn't have a dot, so it's not referring to a point. It's kind of weird naming convention. It's kind of hard to tell there. It looks like the M is also a little bit italicized, but when you're writing by hand, I don't think there's a good way of denoting that. And you can define it by any 3 points. So these are kind of some very basic building blocks of geometry that we're going to be referring to here. And let's see, I've got to give you. I've mentioned these other, or one of these other terms. Let's give you this. Collinear points are points that lie on the same line. Seems to make sense. They coexist on a line. And coplanar points are points that lie in the same plane. So while there are, it only takes 2 points to define where the line exists, there are infinitely many points on that line. Actually, there are infinitely many points between those points A and B alone, which will not let you worry about infinity just yet. By the way, my wife has a fear of infinity. Does anyone know the word for the fear of infinity? Apeirophobia. Not spelled like the word appear, like ta-da, I just appeared out of nowhere, but yeah, apeirophobia. So my wife doesn't allow me to talk about big numbers. So she gets nervous when I'm talking about space or the number of atoms in the universe or things like that. Yeah, so I should have, maybe I'll have to put a spoiler at the, description of this video so she won't watch it, or anyone who's apeirophobic. So let's see, coplanar points, just as it only takes 3 points to define a plane, there are obviously infinitely many points on that plane. Side question, actually. How many lines are on this plane? Thoughts? How many unique lines would be on that plane? How many lines do you see on that plane right now? I mean, we see like 4 of these pseudo boundaries, at least of our sketch. But I could also have the line AB, I could have the line AC or CB. But then there are all of these infinitely many points on those lines. So here's another line between A and B, so I could have that line. There are infinitely many lines on that plane. Obviously, some of them will be parallel, some of them will be perpendicular, some of them will be, what's the other, skew? Is that the right word? I'm trying to recall.
Not on a plane.
Not on a plane.
Skew is 2 lines that occupy different planes.
Oh, yeah, I couldn't remember.
So you've got, what did you say?
Scalene, when you have 2 lines that intersect but not at a right angle?
Oh.
I can't recall. Wow. Well, nonetheless, we'll discover together as we continue through this text. I can't recall. I think there's a word for it, but we'll discover that. I'll let you Google it. You're the ones on the internet watching this video. Well, we in this classroom are not. So here we go. Naming points, lines, and planes. So mathematics is a language. There's many symbols used to describe these objects. So here I would have what would be called a diagram. All right. So this is like my sketch. And then I have different conventions of referring to things. We've already referred to, right, plane, A, B, C, and line, A, B. But yeah, so I've got to give you a series of symbols so that when we talk about math, when we write about math, we'll be describing it the same way. So it says give 2 other names for, how do you think I would read this out loud? For, yeah, line PQ is how you would read that. That's in quotes. Those are my weak sauce quotes there. So give 2 other names for line PQ. So let's see, the line that we're talking about, 2 other names for line PQ and for plane R. So this is the line we're referring to. What are you guys' thoughts? Do you see another name for that line? Aha, I like it. So we could refer to it as QP, but I'm not just going to write QP like this. Man. Here we go. I forgot how to write over the summer, guys. I'm sorry. I'm going to write that with the arrowheads on this little line segment over the symbols QP. So PQ and QP are referring to the same line. What's another name for that line?
Line N.
Line N. Yeah. Line. Looks like it's a lowercase n, so that's what I'll do. Line N. Good, good. Let's see. How about for the plane R? So the plane that it's referring to here is this. Okay, there's R, so it's referring to this surface, right? Imagine it's in that isometric view that we were referring to. What's another way I could refer to that plane? I just kind of drew all over our points. What did we say earlier? Any 3 points can be used to define a plane. Thoughts?
VST.
So let's see. So plane V, S, and T. I like it. Another one? Yep.
TPV.
Let's see. T, P, and V. Yeah. And so those are referring to the same plane. And that's one of the things that will be interesting about this is that there will be multiple synonymous, I think I'm not an English person, names for the same object, right? So there's multiple ways of referring to the same object, but there are also, I would argue, infinitely many wrong ways to refer to the object. So yeah, so for instance, a wrong answer for A, what would a wrong answer for A have been? What's a non-way to describe line PQ? Yeah.
R.
Line R? Yeah. Which is a plane, right? Another wrong answer would be ST, which is a line, but it's not the line that I'm referring to. There we go. That's a little bit better. Right, that there's a whole lot of other lines. There's lines that weren't drawn. There's line VT, right, that are in play here, but are not the line that I'm referring to. And is there another plane that you guys could describe from this sketch? Another like, was there any wrong answer for question B? Yeah.
How is the VST
So let's see. So you're asking about this one, VST, whether or not it's a good name for the plane.
Well, let's see, the points that are collinear.
Well, 2 of them are, or actually any 2 of those are collinear, but V is still on the plane. So any 3 points that are not collinear. Oh, let's see. Well, oh, sorry. Wow, my bad. Here we're talking about naming conventions, and I was answering this. I think I'll call this A part 2. My bad. You got me. You got me good. Because yeah, that they could have just. Come on, guys. We could have called this part B. We could have called this C. We could have called this D. Man, my bad. I'm embarrassed, friends. But good save. Good save. So yeah, so this is A part 2. This time it's personal. Plain VST, yeah. So this requirement was not the one that I was referring to. So back to my question, is there a plane that is not plane R in this drawing? Yeah.
M.
Plane N?
M.
M. Well, M is a line, so it wouldn't be referring to plane R, I agree, but is there a plane, a 3-point name perhaps? Yeah, so QVP. In fact, any of them would have to contain point Q, or that's the only point that I currently have labeled that is not on the plane. And so any plane that I imagine that's at that, that passes through or includes that point would not be included. Let's see. Here we go. Let's give you some more. Question.
So, would the definition that says that a plane has to have, like, it has to be three points that aren't on the same line?
Mm-hmm.
So would VST not work because the S and T are on the same line?
S and T are collinear, but V is not. Okay.
So,
Yep.
but so in the definition, do all 3 points have to be on different lines, or?
Well, any 2 points are already. I could imagine a line that goes through any 2 points. So all three can't be on the same line.
Okay.
Yeah,
All right.
yeah, good clarification. So let's see, let's give you guys some more to think about in terms of naming conventions. Oh, wait a minute. You guys, I forgot. There was the real part B. Man, this is amazing. I love this. This is great. So here's part B. Like if it had a Twitter handle, it would be the real part B, and then like you'd be like, oh, that's the one that I meant to be following, not the fake one that I thought was the real guy this whole time. Let's see. Name 3 points that are collinear. Does that exist in this drawing? I know I've drawn all over it, but collinear. So 3 points that exist on a single line. SPT. I think those are the only ones. S, P, and T. And then name 4 points that are coplanar. So we'll call this B part 2. Man. So any non-Q points. Right? Or thought? Question?
VTSP.
V, T, S, and P. Yeah. Sure. So those points all exist on the same plane. Which, by the way, there does exist a plane that passes through Q, P, and S, which also would have T on it, I just realized. Like the plane that is made up of this line and has Q on it. So it would be like, imagine this like tilted, if I was able to draw it. This plane would also have T, P, S, and Q on it. So that would be an alternative answer. All right, very good. So let's take a look at some more naming conventions. All right, so here are some defined terms: segment and ray. You might not have a chance to write all this down. We're running a little low on time, but don't you worry, we'll be fine. Let's see, the definitions below use line AB, written as AB with the little arrows, right? And points A and B. So let's see, a segment. The line segment AB, or segment AB, written as AB, let's see, one of these things is not like the other, friends. What's that one missing here? Yeah, it doesn't have the arrows. Okay. Consists, oh dear. Whoa, I undid too far there, that's all. So let's see, consists of the endpoints, A and B, and all the points on AB that are between A and B. So here's a line, travels infinitely in both directions. A segment is truncated. I done sliced that line on 2 ends, right? So it's been truncated. So segment AB can also be referred to as segment BA, and notice that the naming convention, the symbol here, matches the diagram rather well. You don't have to draw little dots on that, so that's going to save us time. Mathematicians in general are efficiently lazy people, where we try to just communicate using, you know, some amount of efficiency and elegance without making things unnecessarily complicated. So here's so our segment. Question: how many points are on segment AB? I think I said it earlier in the video too. Not about this particular segment, but just in general. Thoughts? Yeah. Infinitely many points. In fact, imagine I pick point C right here. There are infinitely many points between there. If I move C closer, there are still infinitely many points between C and B. The closest you can think of placing a point that is not B, but still on the segment, there are still going to be infinitely many points in between them. It's crazy. Okay? Now this is where geometry, we have this ideal picture in our mind. We understand, okay, there are infinitely many points, or we can imagine this is what a perfect circle looks like, but these things do not exist within our universe. Okay? These things don't, like, I can't necessarily subdivide reality beyond that, because eventually you get to units of measure that are so small that we can no longer subdivide them. We're talking like quarks, right? Or we're talking about measurements of time that cannot be subdivided any further. But in the world of geometry, we're imagining these planes and these lines in this space where we can talk about specifics like that. Let's see, and then we've got ray. A ray has an endpoint and then still travels infinitely in one direction. These are different rays. Okay, so notice that, let's see if I can use an algebraic term. The name of a ray is not commutative. So AB and BA are different rays, right? And you can see that pictured right there. Let's see, where's my mouse done be at here? Opposite rays. I think we're about out of time, friends. So we're going to have to say goodbye. Thanks for visiting, internet friends. It was great to have you. Comment in the comments. It'll be great. Bye-bye.